This is a video presentation of Chapter 1, Section 2 in the 7th grade Holt textbook entitled Exponents. And here what we're going to have as our objective is to be able to represent numbers using exponents. So let's look at the definitions here, because the definitions are key into understanding the different parts that are related to an exponent. We have the definition of power. A power is a number produced by raising a base to an exponent. A number produced by raising a base to an exponent. Exponent is the number that tells how many times to use the base as a factor in a power. The number that tells how many times to use the base as a factor in a power. And the base is defined as, when a number is written as a power, the number that is used as a factor. Base, when a number is written as a power, the number that is used as a factor. So, let's break down this first question here in example 1, 4 to the 4th, by talking about those different definitions before we jump into the actual problems here. There were 3 terms they just defined for us there: base, exponent, and power. This entire expression, 4 to the 4th, is a power. And the power is made up of 2 parts, base and the exponent. The base, which is what most of you would call the large number that's written, is the number I'm going to end up using in a multiplication problem. Now you're saying, multiplication problem, what are you talking about? Well, power is really a giant multiplication power. So I'm multiplying numbers together. But the base tells me what number it is that I'm actually using in the multiplication. The trick is here, it's the same number being multiplied together over and over and over again. It's not a problem like 2 times 3 times 6 times 7. It's a bunch of 4s. How many 4s? Well, that's what the exponent tells us. That's the little number here. The exponent tells me how many times I'm going to use that base in the multiplication problem. Now, perhaps this first example is not so great because they're both 4s and it doesn't really give us a lot of clarity. So let's skip down to B for a minute and see that. Notice that I'm writing a multiplication problem here in 7 to the 3rd of all 7s. How many times is 7 in that multiplication problem? 3 times. Notice that the exponent here is 3. That's what the exponent is. It's how many times that number appears in that multiplication problem. Other than that, there's nothing to it. All I have to do to solve 7 to the 3rd is 7 times 7 times 7. 7 times 7 is 49, times 7 again is 343. I used 7 as a factor 3 times. So if I go back and look at this A problem, even though this one would be very hard to screw up, I'm using 4 as a factor 4 times. In other words, I'm doing 4 times 4 times 4 times 4. It's in there 4 times because the exponent is 4. The number I'm using in the multiplication is 4 because this large number, the base, tells me it is so. So 4 times 4 is 16, times 4 again is 64, times 4 again is 256. Now the last one is the easiest question of all. It would say I'm supposed to use 19 in a multiplication problem, but since the exponent is 1, it only shows up 1 time. I don't even need to write a time sign here. 19 is used as a factor 1 time. The answer is just poor old lonely 19. Now, a little bit different slant on the same type of problem here. What they're giving us here in example 2 is they're giving us the base, that big number, and they're telling us what the power equals, what the whole deal is supposed to equal. And we're supposed to figure out what the exponent would be to make this work. So in the A question there, since they've given us the base of 5, what we're doing is we're just going to start multiplying 5s together. And we're going to keep multiplying 5 together until we get to that 625 number. Once I get to that 625 number, I'm going to say, how many times did I have to multiply 5 together to get to that answer? How many 5s were used in that multiplication? Right? How many over 5s I had to use is the exponent and the answer to the question. So, I start off with 5, and I multiply it with 5. That's 25, not 625, so I have to keep multiplying. Multiply it by 5 again, that's 125. Not 625 yet, keep multiplying. This time when I multiply by 5, 125 times 5, that is 625. Since I got to this number, I say stop. And I say, how many times did you multiply 5 together? How many times is 5 in that problem? Well, notice there's 4 of them. So the mystery here is solved. The exponent has to be 4 because 5 is in this problem 4 times. So the power here would be written as 5 to the 4th. 5 to the 4th is equal to 625. We'll do the same thing in B, but it's just different numbers. It's supposed to equal 64, and this time the base is going to be 2. So I'm going to start multiplying 2's together. I do 2 times 2, that's 4. Not at 64 yet. Times 2 again is 8. Times 2 again is 16. Times 2 again is 32. Times 2 again is 64. Well, since I have my number here, I stop and I say, how many times is 2 in that problem? Well, 2 is in that problem 6 times. And remember, the number of times that's in there is the exponent. So the power is written as 2 to the 6th power. 2 to the 6th power equals 64. All right, let's go ahead and take a look at example 3. On Monday, Eric tells 3 people a secret. The next day, each of them tells 3 more people. If the pattern continues, how many people besides Eric will know the secret on Friday? So on Monday, 3 people know, because he told 3 people on Monday. And each of the days of the rest of the week, he's going to multiply that number by 3, because each of them is going to tell 3 people. So on Tuesday, 3 times as many people know as those who knew on Monday. On Wednesday, 3 times as many people know as those who knew on Tuesday. On Thursday, 3 times as many people know as those who knew on Wednesday. On Friday, 3 times as many people know as those who knew on Thursday.